All right, on to part B of this week's instruction, function key features. So right now we're going to go over the key features of those 4 functions I was talking about in the previous video. First, we're going to do domain, then range, then x and y intercepts, and then axis of symmetry and vertex. So I've changed how I organized this video a little bit. Instead of doing it directly from the Prezi, I just snipped everything into OneNote to make it easier to create this video. First, we're going to go over domain. Now, in this point in your math career, you should remember that domain is always the x values. So domain is always the x values in our functions. And we remember that x values are like our inputs into the function. They are what are being put into f of x in order to create our y values, our outputs. So the video on the Prezi explains it like f. Now we can use any letter here, but we normally use f. F is our function, and x is what is being input into f to output our y values. And x, like we just remembered, represents our domain. So the set of all x's is called our domain. And the set of all y's are called our range. So here, in this example, we have this function f of x. Now, when we're asking about domain, remember, we're thinking about all of the possible x values that are on this graph. Now, as you can see on this graph, f of x is what is called undefined for anything lower than -6 and anything greater than 7. You see, there are no more points over here. That means that -7 is undefined for y. -8 is undefined for x. There is no definition. There is no definitive point at those values. So our function starts up at an x value of -6, and it ends at an x value of 7. Now remember, for domain, we're only caring about these x values. So in this example, we always read a graph from least to greatest. Our lowest x value is -6. And our greatest x value, our max x value, is 7. So when we're being asked for the domain, here over here it had this little answer box, our lowest x value is -7, and our max x value, oh my gosh, so sorry, our lowest x value is -6, and our max x value is 7. So in inequality notation, which is what this is, inequality. In inequality notation, what you guys used mostly in Algebra 1, our domain is all values between -6 and 7. Or you can read it as x is bigger than -6, but less than 7. Bigger than or equal to, or less than or equal to 7. So let's try it now on our 4 functions that we learned about, or we reviewed in the previous video. We have first, this is absolute value. So when we're asking about the domain, remember we always read left to right, least to greatest. Our lowest x value, now I know it doesn't show arrows, but there should always be arrows here, meaning it keeps going. So our lowest x value is negative infinity. It keeps on going forever in the negative direction. It's an awful arrow. Well, I can't draw a straight line today. And then our max x value, our greatest x value, keeps going forever in the positive direction as well. In other words, our domain is all real numbers. In inequality notation, what you guys mainly used in Algebra 1, we would write this as negative infinity is less than x. Now, it's not less than or equal to because we can never be equal to infinity. So, negative infinity is less than x is less than infinity. Set builder notation, normally we just call this set notation, but set builder notation, we remember set squiggly. So we start with our squiggly bracket, x such that, oh my gosh, what am I doing? We know we don't have to write the such that symbol because our domain is all real numbers. So we just say x is an element of all real numbers, end squiggly bracket. Interval notation is where you go from least to greatest. So our least x value is negative infinity, and our max x value is infinity. Parentheses around both because we can never equal infinity. Now here we have a quadratic. So again, we're looking at domain. That's our x values. So we ask ourselves, what is our lowest x value? Again, there should be arrows here. So what is our lowest x value? When do you stop going down and having a corresponding value for x? Well, you never stop going down. Our least value is negative infinity. And then our max value, when do you stop going up? You never do. So our max value is also infinity. So just like absolute value, again, our domain for quadratic functions, our verbal description of this is all real numbers. Inequality is the exact same thing as before. Negative infinity is less than x is less than infinity. Set builder notation, same exact thing. X is an element of all real numbers. Interval notation, negative infinity to infinity. Then we have, you guessed it, a cubic function. Remember, cubic functions have that squiggle in them. Again, there should be arrows here. And we first ask ourselves, what is our least x value? When do we stop going down the x-axis and having a point corresponding to that x value? Well, we never stop going down and we never stop going up. So again, all real numbers is our domain. That means that all of these are the exact same as the previous functions. Now here is where we get a little bit different. This is a rational function. I can tell it's a rational function because I have a vertical and horizontal asymptote. Now, you have to ask yourself, looking at this, why is it not zooming? Oh no, did it freeze? Okay, there we go. So you have to ask yourself, what are your x values? So we, again, recognize our least x value is negative infinity, and our max x value is infinity. However, there is a line in the middle that x cannot be. There's an asymptote here. The asymptote is x equals 0. That means x cannot be 0. So that affects our domain. X is everything except 0. So inequality notation, this would be x is bigger than 0 and x is less than 0, but x is not equal to 0. Set builder notation, remember set squiggly, so you do squiggly bracket, x such that x is not equal to 0, and squiggly bracket. Interval notation, our lowest value is negative infinity. We go up to, when do we stop? Remember, interval notation, you read left to right. So you ask yourself, when do we stop going up? Oh, we have a stopping point right there at 0. And we're not equal to 0, so we put a parenthesis. And we start back up right after 0. And then we keep going to infinity. So that about sums it up for domain. We went over the 4 functions: absolute value, quadratic function, and cubic and rational functions. And now let's look at our range. Remember, right before I went over domain, I described exactly what is happening with domain and range when we're dealing with functions. Our F, we called it. Remember, domain is the set of all x values. It is the set of all x values being mapped, it's called, into F and producing f of x, or our y values. And the set of all possible y values is called our range. So here, when we're talking about range, it's the exact same thing as domain, but now we're just dealing with y. So looking at this, first, you guessed it, absolute value function. We look at our y values, and we always go least to greatest. So what is our least y value? When do we stop going down? Well, we stop going down at 0. And when do we stop going up? We stop going up, there should be arrows here, at infinity. So our verbal description of the range is, of range is everything bigger than or equal to 0. Wow, something is going wrong with my surface. So in equality notation, this would be y is bigger than or equal to 0. Set builder notation, set is squiggly bracket. Ooh, great squiggly. Squiggly bracket, y such that y is bigger than or equal to 0. Interval notation is always read least to greatest, so bottom up. Our lowest value, and we're equal to 0, so we put a bracket. Our lowest value is 0, and our max value is infinity. So that was absolute value. Then we're looking at our quadratic function. Again, looks like our lowest y value is 0. And our max y value, there should be arrows, is infinity. So our verbal description is the exact same as absolute value. It is everything bigger or equal to 0. Sorry about my shorthand there. Inequality, same exact thing. Y is bigger than or equal to 0. Set builder, same thing. Y such that y is bigger than or equal to 0. And interval notation, exact same. Our lowest value is 0 and it's equal to 0, so I put a bracket. and infinity. Now here we differ a little bit. This is again our cubic function. We always go least to greatest. So our lowest y value, oh, it's different this time. Our lowest y value is negative infinity. And our max y value is infinity. So our verbal description is all real numbers. In inequality notation, this would be our lowest value is negative infinity. We can't equal negative infinity, so it's just a less than symbol. Y, another less than symbol, infinity. It goes from negative infinity to infinity. Set notation, set squiggly, so you do squiggly bracket. Y is an element of all real numbers. Interval notation, our lowest value, and it's not equal to, is negative infinity, and our max y value is infinity. And lastly, we have our rational function. So here, our lowest y value is in negative infinity. Our max y value is infinity. However, there is a line in the middle that y cannot be. This is again another asymptote. This is our vertical asymptote. Oh, vertical. This is our horizontal asymptote. Y equals 0. So here, our verbal description of the range is everything except 0. Oh, what is going on? Everything except 0. So in equality notation, this would be y is bigger than 0 and also y is less than 0, but not equal to. Set builder notation, this is squiggly, set squiggly, so you do a squiggly bracket, y, such that y is not equal to 0. That is the only thing y cannot be. Interval notation, our lowest y value, remember interval is least to greatest, so our lowest y value is negative infinity, and we keep going up until we hit 0. We can't be 0, so you put a parenthesis, and we start back up at 0, and we keep going up. So we're going up, we're stopping at 0, and then we're starting back up at 0, and going all the way up to infinity. Well, now it's not unzooming. There we go. So that's it for range. Remember, range is your y values, and you go least to greatest, lowest to highest. So now we're going to get into x and y intercepts. In order to find x and y intercepts, you can do one of two things. Either you can graph it and look. Actually, you can do three things. So either you can graph it and look, or you can plug in 0 for x or y, depending on which intercept you're trying to find, or you can use your calculator. Right now we're going to go over graphing it and also plugging in 0 for x or y. So first we're going to look at this linear equation and graph it. Now, as you know, whenever you're confused by graphing, you should create a table. So I'm going to create a little table here, an x and y table. And x is my input, so I'm just going to pick numbers for x that will output a whole number for y. So if I'm looking at this linear equation and I'm thinking about inputting 1 times 1/2 is going to be a fraction. This means that my output isn't going to be a whole number, making it very hard to graph. So I'm thinking about x values that will create whole number y values. So the easiest one here is 0. 0 times 1/2 is 0, minus 3 just gives us -3. Easy enough. Again, I'm not going to input 1 because that's going to give me a fraction. What I am going to input is 2 because 1/2 times 2 is 1. And 1 minus 3 is -2. Let's think of another one. 3 won't work. That will be a fraction. 1/2 times 3 is 1.5. That's a decimal or fraction. So I'm going to input 4. 4 times 1/2 is 2 minus 3 is -1. And then really, I only need 2 points here. Whenever I'm graphing a linear line, you only need 2 points. But we'll go above and beyond and do these 3 points. So I have 0, -3. I have -2. Why did I say negative? So sorry. We input a +2 there. So 2, -2. And 4, -1. And then I am just going to connect those points and draw my line. So I have my line, y equals 1/2 x minus 3. And so now you can see, okay, you do clearly see your x and y intercepts. My x-intercept is where the line intercepts the x-axis. So right there, I have my x-intercept. It is where it intercepts the x-axis. This point is 6, 0. That's my x-intercept. And in fact, whenever you have an x-intercept, your y value, this right here, your y value will always be 0. And when you're thinking about your y-intercept, this is where your line intercepts the y-axis. That's this point right here. This point is 0, -3. And no matter what, when you're thinking about your y-intercept, the x value will always be 0. Your x value will always be 0. This is how you can find these algebraically and not on the graph. We know that the x-intercept will always have a y value of 0, and we know the y-intercept will always have an x value of 0. So let's try that concept on a different line. What color? It's blue. Okay, so let's do 5x plus 6y equals 30. If we're first trying to find the x-intercept of this graph, we know that the x-intercept will always have a y value of 0. So to find the x-intercept, all you have to do is apply a y value of 0, meaning in for y, you are going to put a 0. And then you just solve for x. So 6 times 0 cancels to give you 0. And then you're left with just 5x equals 30. To get the x by itself, you divide by 5. And x is 6. Well, why did I cancel that out? So 30 divided by 5 is 6. That means our x-intercept is 6, 0. Now for the y-intercept, we have 5. Now this time we know that the y-intercept is always going to have an x value of 0, meaning we're going to apply 0 or input 0 for x. So 5 times 0 cancels to give 0, and you're left with 6y equals 30. Divide by 6 to get y by itself, so y is 5. That means our y-intercept is 0, 5. So, long story short, whenever you're trying to find the x-intercept without a calculator and you don't feel like graphing, or you don't have a graph, you plug in 0 for y. And whenever you're trying to find the y-intercept, you plug in 0 for x. Well, that looks like a y. X. Okay, last thing. We have axis of symmetry, AOS, and vertex. Now, in the video linked on the website, it had you taking this equation right there, and it went through converting that from standard to vertex form. Now, the reason they have you converting from standard to vertex form is because you cannot easily find the vertex in standard form. When you're looking at the standard form, it's just in ax squared plus bx plus c form. It doesn't easily showcase the vertex, but vertex form does. Whenever you're in vertex form, we know exactly where the vertex is, and we'll go over that in a second. In order to convert from standard to vertex form, earlier in the year, we learned that this process, going from standard to vertex of a quadratic, is called completing the square. This is something that you will need to remember how to do for pre-cal, but because of everything that's going on, I'm not going to go through it right now. I think it's a little bit too much and a little bit too over the top. But if you want to do a refresher, you can, of course, brush up on completing the square, but for now, we're just going to look at this vertex form. When a quadratic is in vertex form, we know that the vertex is always the hk. And we know that the h is the number directly after the x inside the square, and the k is the number at the end. But we also remember that the h is backwards. It's the tricky number. So our x value of our vertex is not -2. It is a +2. But our k value is 16. So if I'm going to quickly graph that, 2, 16. Now, this graph is too small to graph 16, so it is going to go up by 2s. So I'm going to go up by 2, so that's our 2, and then I have 2, 4, 6, 8, 10, 12, 14, 16. I'll draw that on the other side. So 2, 16, that's our vertex right there. Now, from transformations, which actually that's going to be next week's topic, transformations, we remember that if we have a negative out in front, that means that our function has been reflected, meaning it's upside down. So I know that this is going to be a downwards facing parabola. Well, you can't really see the green very well. I guess I'll just keep doing black. It's going to be a downwards facing parabola, and I knew that I was graphing 0, 8 there because of what we just learned with the intercepts. So the y-intercept I just quickly calculated. The y-intercept has an x value of 0. So I just quickly plugged in 0 for x. 0 minus 2 is -2. -2 squared is 4. 4 times -2 is -8. plus 16 is 8. So I have a y-intercept right here of 8, 0. I'm sorry, 0, 8. And then quickly, well, I sketch my graph. So my vertex is 2, 16. And my axis of symmetry is the line that I could fold this graph over and have everything on each side line up. It's the line going directly through your vertex. This axis of symmetry is always the x value of your vertex. So x equals 2 is our axis of symmetry. If you have any questions about either of these videos that I have posted here, please make sure you complete the I am confused form, and I will try to respond to you within 24 hours. Thank you.